Number 3. The surface area of a hot air balloon A in meters squared filled with hot air is given by the function AR equals 4 pi r squared, where r is the radius of the balloon in meter. The radius of the balloon is increasing as a function of time in second, according to the formula RT equals 2/3 T cube. T is more or equals to 0. Okay, so 3A. State the surface area of the balloon as a function of time. State the surface area of the balloon A as a function of time. So this is composite. Okay, so we have two formulas here. AR, area, in term of r is 4 pi r squared. And then radius in term of time is 2/3 T to the power of cube. So the surface area of the balloon A as a function of time is AR to the power of T. AR or ART actually. Okay. So you have to substitute the RT to inside of AR. Okay, so where do you have to substitute? So you have to substitute this inside AR where R is. Okay, so this is function of R. This is something like let's say you R equal to something, so you replace this with R is. Okay, so it become 4 pi. The R you place with 2/3 T cube, and here is R squared. Okay, so simplify, so it becomes 4 pi 2/3 pi cube is 2/3 squared also, so it becomes 4/9 T to the power of 6, because 3 times 2. Okay, then multiply 4 times 4 becomes 16/9 pi T to the power of 6. Okay, that's all for A. For B, find the surface area of the balloon after 2 seconds. Okay, you just replace the value of, okay, the value of T as 2 in this case. Okay, so AR, area, in term of T equals to 16/9 pi, and then replace T as 2 to the power of 6. So you get just press calculator. 16/9 times 2 to the power of 6, then you will get 113 7/9 pi m squared. Okay. Okay, number 4. A cylindrical container of radius 20 cm contains 200 cm cube of water. The container is filled with water at a constant rate of 100 cm cube per second. A. Write the formula of A1, the amount of water in the container. V after T second. Okay, so the container already has 200 centimeter cube of water, and then it is filled with water at a constant rate of 100. So for A1, it will be V equals to, or V in term of T equals to 200 plus 100t. Okay, how did I get this? It's already has 200, so 200 plus 100 times t, because if t equals to 1 times 100, then you can calculate the volume of water. Okay, then A2, the height of water in the container H in term of V. This is according to this formula. So actually we know also that in order to calculate volume of water in the container is V equals pi r squared H. Okay, and so what we have to do, because the height of the container in terms of V, so you just move pi r squared to the other side, so V over pi r squared equals H. Alright, so that's all for A2. For A3, the composite function. The composite function HVT, that is substitute VT inside HR. So write down again. Okay, you have already VT, and then the one that we have for A2 we didn't write in terms of the function. Function of HR equals to V over pi r squared. Okay, so for A3, HVT, okay, you replace VT inside H. Okay, so you place this inside here where V is. So HV, so V replaced with 200 plus 100t over pi r squared. And we already know that the value of r is 20. Radius is 20. Replace. So 200 plus 100t over